One of the most known heuristic methods for PID tuning was developed by Ziegler and Nichols. The authors developed two kinds of approach, and at the first time they used a closed loop to define the values for the PID parameters. After that, they developed another kind of approach in this way using a open loop based on a first order process. In my screen, you can see the equations for both of them. In the first approach developed by the authors, the objective was to increase the gain of the controller until the process gets unstable in a cycling way. So based on that, they could measure the ultimate gain and also the ultimate period. And based on this both information, the user would be able to define the values of Kp, Ti, and Td. The main disadvantage of this method is that for real application, to stress a system to oscillate at its limits, it's not something trivial, because as you know, we are talking about petrochemical process, and deviations from the process can lead to accidents, incidents, and etc. So because of that, they developed a second approach to define the values for the Kp, Ti, and Td. The second approach was based on an open loop. In this way, instead of using the ultimate gain and the ultimate period, the nomenclature now used would be the delay or dead time, time constant, and also the steady state gain. And what happens in this case is that in an open loop, the user do a disturbance in the process and observe the response of the variable. And based on the dead time to observe some kind of modification in the variable, and also how much time it gets to produce 63% of the final results, and also with the calculation of the deviation of the variable and the disturbance, the user would be possible to define the Kp, Ti, and Td. But the Ziegler-Nichols method is not the only one available in the market. You can see here in my screen that we have other authors that propose similar approach to solve the PID values needed to do the PID tuning. Some of them is CHR method that was developed by Schien, Horns, and Heswick, and we have also the Cohen and Kuhn, but many others are available. And the approach is very similar, using the time constant, the dead lag or dead time, and also the constant gain. The user are able to define the values that it best fits for the PID controller. Something to mention is that each method best fits depending on the process characteristics. So here you can see two graphs, and to the same process conditions and to the same disturbance produced in the process, depending on the kind of process, we can have the Ziegler-Nichols, and you can see a lot of deviation, and the CHR with a small deviation. And in this other process, we have a lot of deviations, and some methods are more stable to the deviation, to the disturbance in the process than the Ziegler and Nichols. In any case, these methods can be useful for the first approach to define the values to add in the PID controller. How easy to do that depends on the process, because here when we go to the field, we are not dealing with equations, we are not dealing with Laplace transfer or other kinds of differential equations and etc. We need to evaluate we need to do changes in the controller, we need to evaluate the process, and based on that define which are the best values for the PID.